All right, good morning and welcome to Master Talker online class. In today's video, we are going to be doing physics practical experiment 14 of this is physics practical, physics practical first semester. Okay, and this practical is about a work done on a spiral spring. Right, it's very simple practical. Now they said to determine, the main aim is to determine the work done on an elastic spring. Okay, the procedure is below is a diagram which shows how a mass m is dropped from a height h which is equal to 5 cm. So the height is from here to here, which is the same thing as the one that they're showing us here, 5 cm. Okay, on a vertical spring. Then I say that the stretched length L, the straight length LS, okay, of the spiral spring is 8 cm. So you have to write it down that they gave us that our LS, they gave us our LS to be 8 cm, because according to what we are going to be filling here, we'll be needing the value of LS. Okay, so now we have that okay, they say that, and the falling mass compresses the spring to a length L. Okay, when this mass drops here, it compresses this spring here. So this LS is the normal length of that string, or spring, sorry, the normal length of this spring. So when you drop this thing here, you will notice that the spring is going to reduce. But we are not actually going to do the practical. I'm just going to show you how to fill in this your table. Then we plot the graph together. So this is serial number. This is number 1, number 2, number 3, number 4, number 5. So the first thing we do is to measure. Now, first of all, please, I'm very sorry that I'm not with a very good measuring ruler, meter rule, okay? But we are going to manage this one that I have here. I was looking for it and my son broke it, so I couldn't find where the other one is. So let us just manage this one. So the first thing you do is to measure the normal length. They told us that here is 5 cm, but if I measure, I'm getting that this is 1, 2, 3, 4, 5, 5.1, 5.2, 5.3, 5.4. The actual measurement is 5.4, but they told us that the measurement is 5. They told us that the measurement is 5. So the scale we are going to be using to feed this thing should be, I think, 5 divided by that 5 divided by that. Where did I do mine? Sorry, 1 minute. Yes, 5 divided by that. The length they gave us divided by the actual length. Okay, then times any other thing we measured. So that is the scale we are going to use. We are not going to be using, normally we are supposed to be using what we measured here, but you saw that they made mistake in their own. So you have to correspond it with the same mistake they made. So for the very first one, now normally this thing is supposed to be 5.4, but they used 5. So for the very first one, we're going to be using 5.0. This is 5.0. You measure the next one. So the height 2. The second height, for the second height here, I'm getting that this is 1. This is sorry, let me shift it very well. This is 1, 2, 3, 4, 4.1, 4.2, 4.3, 4.4, 4.5 according to mine. So I'm going to say 4 times 4.5. So anything you are getting, you are going to multiply by this. So I'm going to say the normal length they gave us divided by the actual length, which is 5. The normal length they gave us, which is 5. They gave us 5. Okay, 5 now divided by the actual length is 5.4. Okay, then you now say equal to, then times the second one we measured, 4.5, to give us approximately 4.2. So my second length here is 4.2. So you are not going to be using the actual thing you measured. Are you getting it now? Because they made mistake in their own. So that is how they want to test your this is. So the next one, number 3, we measure number 3. I'm having that for number 3. This is 1, 2, 3, 3.5. I'm having 3.5. So you come to this place and put your, this is first put it this way, self, 5 over 5.4 then times, I got 3.5, so approximately 3.2. So this is 3.2 approximately. Sorry, 3.2. Please don't make mistake in your own. This thing I did here now will attract minus half mark. So any mistake you do, they subtract half mark for you. So you have to write it out somewhere. Now later you now transfer it into your textbook, okay, or your practical manual. Sorry. So the next one, the fourth spring, we'll measure the fourth one. The fourth one, I'm having that this is 1, 2, 2.1, 2.2, 2.3, 2.4. This one gave me 2.4, so I'm going to be using 2.4, 2.4. The same thing here. The same thing here. Don't forget. The next one is 2.4. So I'm having approximately 2.2. So 2.2. You see that obviously the next one is 1.2, but don't conclude, sha. Let us measure it. So this is 1, 1.1, 1.2, 1.3. Okay, this is 1.3. This one fell at 1.3. Yes, 1.3. So if I put 1.3, 1.3. So I'm having approximately 1.2. So this is 1.2. So it's very easy. So now the next thing we're going to measure, now is the length L. Let us measure the length L. So for the very first one, if you measure the very first one, I'm getting 1, 2, 3, 3.5, 3.6, 3.7, 3.8. I'm getting 3.8. So in this one now, they did not give us initial one to know if they made mistake or not. So I'm using my actual thing I measured. So which is what? 3.8. So we measure the next one. So this is 1, 2, 3, 4, 4.5, 4.6, 4.7, 4.8. I'm having 4.8. So we measure the next one. This is 1, 2, 3, 4, 5, 5.1, 5.2, 5.3, 5.4. I'm having 5.4, 5.4. You see, you are not supposed to conclude that since it's going by 3.8, you keep going by 3.8. Please don't conclude. Always measure. So the next one that I'm having, so I have 3. So the next one, this is 1, 2, 3, 4, 5, 6, 6.4. So this one is 6.4. And then the last one gave me 1, 2, 3, 4, 5, 6, 6.5, 7, 7.1, 7.2, 7.3. So this is 7.3. Okay, so the next thing we do is to say LS minus L. That is, don't forget that your LS is 8. 8 minus all these things. So 8 minus, in fact, 8 minus 3.8. I'll have, I see my calculator, I'm having 4.2. So this side is 4.2. So we'll do the same thing again. 8 minus 4 point this is giving me 1.2. So 1.2. So the next one is 5.4. 5.4. I'm having 2.6. 2.6. So the next one is 6.4. I'm having 1.6. 1.6. And then finally 7.3. 7.3. I'm having 0.7. 0.7. So the next one is we should get is b squared. So let us square all these things. So 4.2 squared gave me 17.64. 17.64. 17.64. So the next one, 1.2 squared. I'm having 1.44. 1.44. So 2.6 squared. Sorry, let us check this again. I think there's an error here. 8 minus 4.8. Oh, this is 3.2. This is 3.2, sorry. So 3.2 squared. I'll have 10.24. So 10.24. See why I said you should do it outside your manual first before you transfer into it. Okay, so please do it outside first. So 2.6 squared is giving me 6.76. 6.76. So the next one is 1.6 squared is giving me 2.56. 2.56. So the last one is 0.7 squared, which is giving me 0.49. All right, now let's go to the other side. For this side, they say we should plot a graph of b squared and determine the slope. So this is where we are going to plot the graph. The problem I'm having now is that I don't even have a meter rule to be drawing a straight line, but we can just manage anything we see. Okay, so, and don't mind you that you don't use pen to draw a graph here. You don't use pen. So, but I'm going to use pen because, like I told you, my son broke my ruler. So let me use pen, and I don't have a pen, so I can't even find where he kept my pencil. So let me use ruler. Let me use pen as my ruler, and pen as well as my pencil. Okay, and I'm going to use pen for you to be able to see it. You know that this is a video, so if I use pencil, you may not be able to see. So the first thing we do is to draw. And if you notice here now, if you notice that what we are plotting against what, h is the one that is in the vertical, so b squared is in the horizontal. So h against b squared. And if you notice that all of them are in positive, so because they are in positive, now, like I taught you in graph, you can go and watch my video on graph. I don't want to waste time so much. Just go and watch my video on graph. So we're going to be plotting it together. So to understand how to do graph very well. So, and why I'm drawing my line here. So, and I hope you know you don't shade. You draw a perfect line, you don't shade. And in fact, this is university. They don't have time to be checking so much in your graph. Let me show you the one that I've already plotted. Now, when somebody see this graph this way, you will see that this is a very neat graph. So when they look at it and they see, this graph is very neat, what will they do? They will just give you your score. They don't have time to start checking if you traced it well. They don't have that time, but just do it well. So let us do it together. Okay, so let's do it together. So we have that this is our y-axis, but we don't call it y-axis because we're not plotting y here. So you cap it. This cap, if you do not cap this thing, they will subtract mark for you. So you cap it and then put that you're plotting h in cm. Yes, you write it that this side is your h in cm. So you now draw for this side and draw for this side. And draw for this side. So you cap it as well. If you draw, you cap. You cap it as well. You cap it. Then you now write that this side is your what? Your b squared. Your b squared in cm squared. Okay? Your b squared. You must write it this way. If you did not write this and I wrote here, they will subtract mark for you as well. Half mark for you. So now the next thing to do is to choose our scale. And in choosing our scale, we can say for every 4 cm. You know that from here to here is 2 cm. So every 10 box is 2 cm. So I want to use for 4 cm. So let me calibrate. 1, 2, 3, 4, 5, 6. My own is 6 in number. Every 2 cm, they are 6 in number. So I will say the highest number here divided by 6. The highest number here divided by 6. So the highest number I'm having here is 5. So 5 divided by 6. So I'm having 0.83. So 0.83. But I cannot use 0.83. So I can use 0. Is either I use 0.8. 0.8. In fact, using 1 self is even easy. Using 1 cm is even very, very easy. So we can just use 1 cm. So 1.0, not 1 cm, but 1.0, 1.0. Okay. So 1.0, 2.0. I can just approximate this thing to 1.0. So, and that person can decide to use, we cannot use 0.9 because 0.9 is an odd number. We cannot use 0.9. The only odd number that is allowed is 1. That's the only odd number that is allowed. But aside 1, you cannot use any other odd number. So I can use 0.9. So no, nobody can use 0.9. I can use 0.84. And that person can choose to use 0.84. Or another person, but you cannot use 0.8. Because if you use 0.8, this number beside it will make it fall outside your graph. So I can only use either I use 0.84 or 0.86 or 0.88 or 1.0. So I decided to use 1.0, and that's the easiest. So here is 3.0, 4.0, 5.0, and 6.0. So you see that this will perfectly fit in. So the next one, for the other side, I'm plotting b squared, right? So I'm going to say that, let me use 44 cm as well. In fact, you write it here that your scale for y-axis we used that every 4 cm is equivalent to 1.0 unit. Okay, so for this one, we want to use 4 cm again. So 1, 2, 3, 4. My own is 4 in number. So, and the highest value here is 17.64. So you say 17.64 divided by, how many did I count? Let me check again. 1, 2, 3, 4. Divided by that 4. That's how to choose your scale. So the highest number of what you are plotting divided by the calibration. So that thing I'm doing that I'm counting is called calibration. So if I divide, I'm having 4.4. Like I told you, we cannot use odd number. So somebody cannot use 4.4 because 4.41 that is there will make it to fall outside. So I can use a 4. Somebody can use 4. You cannot use 4.5 because it's odd number. So somebody can use 4.6 or 4.8 or 5.0. So I decided to use 5.0 because it is way easier. So I can say that here is 5.0. If you add 5.0 again, you have 10.0. Add 4.0 again, you have 15.0. Then 20.0. So let me write this side b in bracket of cm squared. So you give space. So that you don't this thing I did there has attracted half mark minus half mark for me. So so you have to be very, very careful. So now the manipulation we are going to do is for us to change what you are plotting to boxes. So you can write your x and y axis. Now let me teach you how to change to boxes. For y axis, you know that this is what we are plotting to the side of y. Okay, so and we got that for the side of y that these things are in, this is 10 boxes, 20 boxes. So you will say if 20 boxes will give us 1.0. Now how many boxes? We want to convert everything we are plotting to boxes. So how many boxes will give us the first one? How many boxes will give us 5.0 that we are looking for? You cross multiply. So to get each box, you will say 20 times 5 divided by 1, which is just 20 times 5. So to get each of them, I'll be multiplying them by 20 by 20. So for the very first one, I'm talking about y-axis. So you will say that 20 times, and 90 divided by 1 is just the same thing. So I'll just be multiplying each of them by 20. So I just did cross multiply. So 20 times 5 for the first one is giving us 100 boxes. So for the y-axis, this is 100 boxes. You multiply the next one. The next one is 4.2. It's giving us 84 boxes. So the next one is 3.2. 3.2 is giving us 64 boxes. So the next one is 2.2 is giving us 44 boxes. So the next one is 1.2, so which is giving us 24 boxes. So I've converted everything in. I'll now be counting in box instead of looking for all these numbers. I'll be counting in boxes. So let's do the same thing for x-axis. This is for y-axis. This thing I wrote here now shouldn't be in your note. It's your manipulation. It should be in your rough. So let's manipulate for x-axis. For x-axis, we'll say that every 20 boxes, because from here to here is 20 boxes. So every 20 boxes, if 20 boxes will give us 5 units. Now, look at it. 20 boxes gave us 5 units. So how many boxes will now give us? We pick the first one, which is 17.64. So to get anyone I'm looking for should be cross multiply. That is 20 times 17.64 and divided by 5. So which can give us, we press 20 times 17.64 divided by 5. Okay, so I'm having 70.64 70.56. You must approximate it to whole number, which is 71 boxes. So this is 71 boxes. Okay, so or I can even see that this can even cancel this in, so that it will be easy for me. So to get each one of the box, so I'll just say 4 times each of these things. It will now be easier. So 4 times 70, but nothing can divide. I do it normally. I'll just be changing this one. I'll just be changing this one and be putting the next one till I get everything I'm looking for. So 4 times 17.64. So it gave me the same answer, 70.56. So approximately 71 boxes. So you put the next one, that is 4 times 10.24. So I'm having 41 boxes approximately. So the next one is 4 times 6.76. So I'm having 27 boxes. So the next one, 4 times 2.56. I'm having 10 boxes approximately. So finally, the last one, 4 times 0.49. So I'm having 2 boxes approximately. 2 boxes approximately. So we come here now and start counting in terms of boxes. So for x-axis is 71, for y-axis is 10. So I'll say 10, 20. I hope you know that each of the 10 boxes is 10. So this is 10, 20, 30, 40, 50, 60, 70, 80, 100 boxes with 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. So this is 100. Here is 100, which is exactly that 5. Are you seeing it now? So this is 100 against 71. So 71, we count this way. So we have 10. Each of the tick line is 10. 10, 20, 30, 40, 50, 60, 70, 71 is just the next point. So this is my 71. Here is my 71. So don't forget that we don't use this X again. We use just a dot and circle it. So this is my 71. So the next one is 84 against 41. So this is 20, 40, 60, 80, 84. Okay, we're still going to count 4 up. So that we don't make mistake, let's count 41 here first. 10, 20, 30, 40. This is 41. Don't forget I left 4 up. 1, 2, 3, 4. So this is it. This is the point I'm looking for. So the next one is 64 against 27. So 20, 40, 60. I still have 4 up. So let me say 10, 20, 30. So if I remove 3, 1, 2, 3, that is 27. So I still have 4 up. 1, 2, 3, 4. Please count your own very, very well. Take time and count your own very well. So the next one is 10 against 44. So this is just 10 here. 10 against 44. So I have 44 against 10. 20, 40. I still have 4 up. So against 10, this is 10. So I have 4 up. 1, 2, 3, 4. So this is it. You circle it. So the next one is 24 against 2. 20. I still have 4 up. So against 2. This is 1, 2. 1, 2, 3. 2. 1, 2, 3, 4. I have it here. So this is it now. So I'm done. So and then you know that the line of best fit should be, I taught you how to draw it. Just go and watch my video on graph. I'll keep the link on the description so you understand how to do that. So let us just draw our line of best fit. Ruler problem. My own is not perfect though, so let your own be perfect because I'm not with ruler here. So now, if you want to choose your slope, just watch my video on graph. I don't want to start teaching how to choose slope again, but we're just going to choose our own slope. Then let me look for a point to choose. I want to choose this point, and Which other point can I choose? Let's choose a very nice point. Okay, let me choose this point here. So we draw a line like this. I don't have a ruler, so let me just try it here, because if I use this pencil now, it will not work out. So this is my slope. So you call this side change in what is plotted here. So change in b squared in cm squared like this. Why this side should be change in h in cm. Okay, so you now trace this side with a dotted line. Trace with a dotted line. And then trace here with a dotted line. Trace this side with a dotted line. Please make sure you watch my video on graph. That is what will help you plot your own very well. Then trace this side with a dotted line. So for my slope, they say we should calculate slope. So for us to calculate slope, we tell them that, where did they say that? They say we should calculate slope here. We tell them that slope is equal to change in h over change in b squared, which will give you h2. In fact, this is a positive slope because it fell at my right hand side. So h2 minus h1 all over b squared 2 minus b squared 1. So which will give us, so to get our h2 is the one up here. So we say this is even obvious for that one. So we have that this is 10, 20, sorry. So this is 4. So here should be 4.5 because before 5. So it's obviously 4.5. But if you don't know if it is 4.5, how you are going to get it is that you do the same thing again. That 20 boxes gave you 1.0. Now we are no longer looking for boxes. We are looking for numbers. So we'll count the boxes: 10, 20, 30, 40, 50, 60, 70, 80. This is 90. So 90 boxes should give us what it should be there. So cross multiply. So it should be this time. That is 90 divided by 20. So 90 divided by 20. You see, we are getting exactly 4.5. So you can get it this way. So you say that this is 4.5. So 4.5 minus. So for the same thing here again. So this is, this one fell here immediately. So 2. So we use 2 there. So say minus 2.0. Anything you are doing the same decimal point to. So for my B2 now, B2 is the one in the right, B1 is the one in the left. So for my B2 now, I'm going to have that the same thing again. 20 boxes gave us 5. 20 boxes gave us 5. So let us count the number of boxes. This is 10, 20, 30, 40, 41, 42, 43, 44, 45. So 45 boxes should give us what's supposed to be there. So cross multiply again. So 45 times 5 divided by 20. So I'm having 11.24. So if I'm using one decimal places, I'm going to approximate 11.3. So I will say 11.3 minus. So let's do the other one again. So we do the same thing again. 20 boxes gave us 5. So let's count the number of boxes: 10, 11, 12. So 12 boxes should give us what's supposed to be there. So say 12 times 5 divided by 20. So I'm having 3. So that place is 3.0. So this is 3.0. So our slope will now be, okay, so our slope will now be, let's do that, 4.5 minus 2.0. So I'm having 2.5. So I'm having that this is equal to what? 2.5 over 11.3 minus 3. So I'm having 8.3. 8.3. So my slope finally becomes 2.5 divided by 8.3. So I'm having 0.3. So even with the one I did here, you see that I got my slope here to be 0.31. So your slope must fall within the range of 0.3, 0.29, all those small. The difference should not be too much. So I got the same slope, 3.0 here. and sorry, 0.3, not 3 points. You see, this mistake is half mark 0.3. So the this thing I'm using is cm per cm squared, which is setting as 0.3 per cm, because one of these will cancel one of these, so it will be per cm. So that's, and if you do not put this SI unit for your slope, you have already failed. So the next thing we're going to calculate is error in slope, error in graph. So the error in graph is where this one fell out. And you see this one fell out here. So you trace it a parallel line to the other one. This one fell out here. So you trace a parallel line. This is a parallel line. Trace a parallel line. And this one fell out here. We trace a parallel line as well. A straight parallel line. So you trace the straight parallel line. So your W, you know that the formula to calculate your error. So you say that error is equal to error in slope, which we call it SG, and the formula is equal to what? 4W over NR. So which is equal to 4 times. Now my W is the distance from here to here. So the distance from here to here. So you can draw a straight line that will touch the both of them. So just draw a straight line. Look for a point that will be okay for you. So let's draw a straight line. Maybe this point here, and if we trace this point here to maybe some point here, so let's just trace it this way. So this is my W. So you now trace it to this side with a dotted line. Trace it to this side with a dotted line. So I'm traced to this side with a dotted line. So my W will now be up minus down. So we say this one is already 4. 4 minus this point. Now to get this point is we'll do the same thing again. That 20 boxes gave us, sorry, that 4 boxes gave us 20. So let's count the number of boxes. This is 4, 8, 9, 10. So 10 boxes should give us what's supposed to be there. So we have 20 times 10 divided by 4. So I'm having 50 there. So that is not 20 but 2.0. Sorry, what am I saying? 20 boxes gave us 1.0. 20 boxes gave us 1.0. So this is 20, 40, 41, 42. So this is 10, 20, 30, 40, 41, 42. Yes, 42 boxes should give us 42 boxes should give us X. So let us do that. So it will now be 42 divided by 20. So I'm having 1.2. So 2.1. So this is 4 minus 2.1. 4 minus 2.1. So which is giving us 1.9. And if you look at it here, if you look at my own here, when I did here, I'm getting 1.95. You see, so it should be within the same range. So anything you are getting and you're not getting within this range I'm getting here, then your own is wrong. So 1.9. So times 1.9 divided by, don't forget that your n is number of things you did. 1, 2, 3, 4, 5, 6. Sorry, not there, but here. N is the highest here, which is 5. So my n here is 5 times your arrow is the highest in the horizontal. What I plotted in the horizontal was b squared. So b squared. What I plotted in the horizontal was b squared. So the highest here minus the lowest here. So we have 17.64 minus 0.49. So I'm having 17.17. So 17.17. So 17.15. Sorry, 0.15. So the final answer becomes 4 times 1.9. 4 times 1.9 is giving us, we're having 7.6 over 5 times 17.15. So I'm having 85.75. So finally I'm having 7.6 divided by my answer. So I'm having 0.09. 0.09. So that is that for that. So you see, it's very, very simple. So the next one, they say that from the graph, deduce the compression of, deduce the compression that would be produced when a mass is dropped from a height of 4 cm. Okay, from a height of 4 cm. Now, from a height of 4 cm, let us see what b squared will be from our graph. From a height of 4 cm, this is height of 4. So this is height of 4. The height of 4, if you trace from the side of height of 4, on my graph, height of 4, height of 4 from my graph, you keep tracing from 4 to this point, to the point of your graph. So this is my graph, this is the line of best fit. So you trace from that 4 to the line of best fit. It fell somewhere here. So if you trace this side, now, trace it down gently. Don't draw a line. You understand? I just want to trace it down, so that just trace it down that form. Trace it very well. Okay, let me check. It is 1, 2, 3. Sorry, this is 1, 2 on the second one. On the second one, 1, 2. So if we come here, we say 1, 2. So it is at this point. So this point, let's see what this point will be. You do the same thing again. So what do? We say that 20 boxes gave us 5.0. So let's count the number of boxes. 10, 20, 30, 38. So 38 boxes should give us what's supposed to be there. So we say 38 times 5 divided by 20. So I'm having 9.5. 9.5. So 9.5. So now for 9, that means that my b squared is equal to 9.5. So my b will now be the square root of 9.5. So my b will now be the square root of my answer. Will give me 3.08. 3.08. Now, but if it, when I did my own here, I got that it is 8.25. So you see, it's a little bit closer. So it depends on the graph, the way you drew your own graph. You understand? So it should be a little bit closer. So now this is my b. So, and what they're asking me, so we will say that from the graph, so you write for them this way. So like the way I wrote that, I'll tell that the value of b squared, the value of b squared in cm squared from my graph at the height in cm of 4.0 cm, at when height is 4.0 cm from my graph, from my graph is, I got 9.5, right? 9.5. So you will now do your calculation. You now tell them that therefore b squared is equal to 9.5. So my b will now be the square root of 9.5, which is equal to 3.08. Are you getting me? So don't forget that your b is equal to L minus LS minus L. Don't forget we are looking for L, so we should find the length. So what do we have now? We're going to have that, put this one here, 3.08. 3.08 is equal to, my this is always 8 now, 8 minus the L that I'm looking for. So this one come here, this one go here. So my L will now be 8 minus 3.08. So my L is equal to 8 minus my answer, 8 minus 3.08. So I'm having 4.92 cm. Now for the scale they use, scale conversion, you have to convert it like we did before. Scale conversion, the scale conversion, don't forget, should be this. It should be, we measured, they say that it is 5, but when we measure, the actual length we measured was 5.4. So times this length, 4.92, which will give us, so times 5 divided by 5.4. So the actual thing we are going to use is 4.56 in cm. So that is that for that. I think, okay, so the last one, they say we should state 2 precautions you would take if you are to perform the experiment to ensure accurate result. So the first precaution is that I ensure the spring was vertical. You should ensure the spring is vertical. So number 2, I ensure the mass M was dropped along vertical axis on the spring. So like you drop it vertically like this, like vertically, like not just throw it anyhow. So the next one is that I noted and avoid parallel error while using the parallax error while using the meter rule. So that is that for that. So thank you very much for watching this video. Please, in the next video we're going to do the next experiment. So please don't forget to like, share to your friends, comment, and subscribe to the channel. May the peace of the Lord be with you. Bye bye.